Astronomy is a mysterious subject, and every time we make a new discovery in this field, the entire discipline becomes even more mysterious. And this is especially the case when astronomers stare through their telescopes and find something that should not be there. In this case, an object traveling within our galaxy at a speed of over 1.6 million kilometers per hour. That's fast enough to escape the gravitational influence of our galaxy and to send this object spiraling into intergalactic space. But more importantly, we can't identify what this object actually is. It doesn't appear to be a star. It doesn't appear to be a more exotic object like a brown dwarf, black hole, neutron star, or anything like that. It appears strangely light and strangely devoid of the types of elements that we would expect to find in an object like this. And yet, there it is. And though the scientific community would have us believe that this absolutely has to be a natural object, there are some compelling reasons to hypothesize that this might actually be the product of an immensely advanced civilization with objectives and goals that are entirely different from the ones that we understand. All of this and more coming at you on The Angry Astronaut right now. Good afternoon and welcome to another Angry Alien Bulletin. With all of the incredible discoveries that the James Webb and Hubble telescopes and others have made in the distant universe, it's rather surprising when we stumble across something that we haven't detected, in spite of many years of looking, right in our own neighborhood. But this is something that a group of private astronomers, basically backyard astronomers, known as the Planet 9 Project, have managed to do. They spotted an object moving at an astonishing speed of about 1 million miles an hour, or 1.6 million kilometers per hour. That alone is very strange, because the gravitational forces within our galaxy shouldn't be able to push an object to this kind of speed at all. If objects were being pushed at this kind of velocity by the gravitational forces within our galaxy, that means our galaxy would start flying apart, with many objects escaping the gravitational influence of the Milky Way and spiraling out into intergalactic space. And although this does happen, it doesn't happen all that often. And when it does happen, it's very difficult to determine exactly how these objects were propelled to this type of velocity, because even though this object is pretty light by stellar standards, it still weighs anywhere between 83 and 88 times the mass of Jupiter. That's utterly colossal. What sort of force would be necessary to propel something this heavy to a velocity that is sufficient to escape our galaxy? Well, a number of possibilities have been proposed. However, there are problems with all of them. And actually, also, there are problems with a lot of theories regarding what this object actually is, which is one of the reasons why I've decided to call it a UFO. Sure, not a UFO by the standards that we usually judge them. It's not in our atmosphere. It's hundreds of times as massive as our planet, but that doesn't mean that it's not an unidentified object of some kind. And really, this kind of demonstrates how outdated our concept of categorizing these types of objects really is. Now that we are detecting more objects in space, either inside our solar system or outside, that we cannot clearly identify, it might be time to create some new categories. For example, an unidentified orbital object, or UOO, an unidentified interstellar object, or UIO. These are just ideas, but still, I think it's important that we start admitting that unidentified objects exist everywhere in the universe and not just in our own atmosphere, and we need to start categorizing these objects as well. So what is it about this object, which by the way is known as CWISE J1249? What makes it so unique, besides just its velocity? Well, in addition to that, it also possesses a strange composition, much less iron and other metals that one tends to detect in stars and brown dwarfs, which by the way is what some astronomers think this object is, an object that is not quite a planet and not quite a star either. But as I said, there are problems with this theory because it contains a composition very different from any brown dwarf or any star that has been detected in the past. And by the way, planet searching volunteers who look for brown dwarfs have actually identified over 4,000 of them, and yet none of them contain the kind of composition that CWISE J1249 has, and none of them are traveling at this breakneck pace either. So again, what could have caused this type of crazy velocity? Well, some theorize that it might have been part of a globular cluster, tightly packed stars, which result also in tightly packed black holes. Whenever black holes occur in globular clusters, sometimes you'll have orbiting pairs of black holes that by chance happen to evolve right next to one another, again because the stars are so compacted, and CWISE J1249 was just lucky enough to pass between two of these black holes, and that created an enormous gravitational burst of speed that sent it spiraling out of the galaxy. There are problems with this theory, however, because its current trajectory does not suggest that there were any globular clusters on its course. No globular clusters at all from its point of origin, unless it originated from someplace outside of our galaxy, and that seems very unlikely because it's following a trajectory that corresponds with the galactic plane. This trajectory suggests that it came from someplace within our galaxy. Now, another possibility is that it came from somewhere near the galactic core, where there is a supermassive black hole that if it got a bit too close to that black hole, it might also have been ejected by the enormous gravitational pull of this object, not enough to pull it inside, but rather to create the mother of all slingshot events, which hurled the star out of the core area. Again, this is something we've never actually observed. We've seen stars orbiting the supermassive black hole at very high velocities, in some cases actually achieving speeds of a substantial percentage of the speed of light without being completely ejected. So that also seems to be an unlikely scenario. A more likely scenario could be that this was originally part of a binary system where a white dwarf was devouring material off of another star that was orbiting the white dwarf until it gathered too much material, creating a supernova, and the force of this supernova explosion ejected the object. However, if that is the case, supernova explosions usually go hand in hand with strange and unusual materials, unusual elements, sometimes things like platinum or titanium or other unusual metals, things that are completely absent from this object. Now, it does need to be observed in greater detail, and if we determine later on through spectrographic analysis that this object contains a number of unusual or exotic materials that it shouldn't have, that would indicate that these materials might have come off from a supernova blast from a white dwarf star, and then we have our explanation. But as of right now, this object doesn't seem to correspond to that type of explanation either. Indeed, the combination of speed, unusually low mass, and unusual composition makes this object quite unique indeed. And when things are that unique and defy natural explanation, in my opinion, we should also start looking for an artificial explanation. And that's where we start wandering into the area of stellar engines. Alien megastructures capable of relocating an entire solar system from one part of the galaxy to another, or from one galaxy to another. So how do these things work? How do you move a solar system? How do you artificially move a star to the types of velocities that we are observing with this object? Well, it's as simple as reflecting the star's light back onto itself. This is something called a Skotov thruster. And by the way, this animation is from an amazing individual and YouTube creator named Isaac Arthur, and I have his channel linked in the description. Please support him. It's as simple as setting up what is half a Dyson sphere, reflecting the light and energy of a star back onto itself, and that thrust alone, the photons being reflected by the megastructure back onto the star, slowly applies thrust and increases the velocity of the star, and the star in turn drags all of its associated planets with it. And by the way, that is something else that we should be looking for with this object. Does it have any planets traveling along with it? If it does, then a lot of these ejection scenarios simply do not hold any water. If a supernova, for example, were to eject a star, most probably it would blast its associated planets in entirely different directions. So chances are, if this object has any planets orbiting it, it was not ejected by a supernova blast. It might have been ejected by a black hole, though, because a black hole would provide the same gravitational slingshot effect to the star as it would to any orbiting planets. Nevertheless, if through further analysis we find any objects in orbit, that suggests that this object is very different indeed from anything else we have ever detected in the past. But not completely different, because interestingly enough, a very nearby star known as Barnard's star is also traveling at a strange velocity, and it does appear to have something strange in orbit around it, something that makes it wobble a little bit, but something that may not actually be a planet. If you're interested in this particular topic, I have a video about Barnard's star and the potential of it being a stellar engine of some kind in my Patreon channel. If you're interested in getting access to those videos, all the details are in the description. But let's get back to this other object, CY J1249 plus 3621. Yeah, better get used to using those sorts of classifications when you're talking about recently discovered stars. What else is it about this object that makes me think that it might have something artificial associated with it? Well, it's the very nature of intergalactic stars, stars that get ejected from their galaxies. It seems that these things are actually a little bit more common than one might think. Examinations that have been carried out of galactic megaclusters, or just galactic clusters in general, groupings of galaxies, and there are, of course, billions of them throughout the universe, all of them suggest that there's a certain percentage of stars that are outside of the galaxies in these clusters and not inside. Actually, about 17% of the stellar population of all galactic clusters appear to be extragalactic in nature. 17% of all stars are outside of their galaxy, which is very, very strange, and it seems to defy our notions of stellar evolution. There shouldn't be enough matter between the galaxies to form new stars. So therefore, these stars should be ejected stars from their associated galaxies and not stars that evolved independently. That's what one would think. But it's actually not true, because if they are indeed comprised of stars being ejected from their galaxies, as a galactic cluster gets older and older, the population of these stars should increase as more and more stars are ejected from their galaxies by random chance. And yet that is not what we see. Approximately 17% of all stars in a galactic cluster are extragalactic, regardless of the age of the cluster. It can be young and it can be old, and the population of these stars remains the same. How is that possible? The more stars that get ejected over time from a galaxy, the more the population of these stars should increase. Where are these stars going? So that suggests instead that these stars are forming in between the galaxies naturally and not being ejected, regardless of what we think we know about intergalactic space and how little matter there is there to form these types of stars. But if that is indeed the case, then what is happening to the stars that we know are being ejected from the galaxy? Given that the extragalactic stellar population remains constant at 17%, for every star that gets ejected from the galaxy, another one disappears from intergalactic space. Where is it going? Does it just leave the galactic cluster? Well, that seems highly unlikely, because you need not only the velocity to escape from your parent galaxy, you would also need the velocity to escape the combined gravitational influence of the entire cluster, which is a much more difficult feat to accomplish. Here's where I think these stars might be going. They're going to a different galaxy. They're not spiraling out of their parent galaxies at random to some sort of random destination. They have a very clear destination in mind. They want to relocate to another galaxy by design. So for every new star that leaves the galaxy on its way to a new destination, one of these intergalactic stars ends up in another galaxy, keeping the population constant. And what you're looking at right now is something called a Kaplan thruster, which utilizes harvested plasma from a star in order to provide thrust. It actually provides a lot more thrust than a Skodov thruster and could relocate a star at much greater speed and much greater efficiency than the Skodov thruster, and would also explain, by the way, why certain elements are absent from this object. It's because they've been harvested in order to provide thrust. And for those of you who still think that I have flipped my lid, let me introduce you to another star called VVVWIT-08. By the way, the WIT stands for What Is This? And as you can see, there is some sort of disk orbiting this star, an almost completely opaque disk with very finely defined edges, meaning that it can't be dust or anything like that. It has to be some sort of solid object that completely obscures the star, and it is utterly colossal, whatever it is. And by interesting coincidence, this star is also traveling at a velocity that is consistent with a star being ejected from the galaxy. By interesting coincidence, a star with a disc-shaped object that's millions of kilometers in diameter also happens to be traveling at a speed consistent with an extragalactic object. That is just too big of a coincidence, in my opinion. And CY's J1249 plus 362 gives us an even better opportunity for in-depth analysis because it's very close, less than 450 light years away. That is less than 0.5% of the entire diameter of our Milky Way galaxy. An amazing coincidence that we would happen to stumble across such a unique object right in our neighborhood. Unless, of course, these objects are more common than we think. And if that's the case, perhaps incredibly advanced civilizations are far more common than we ever thought. But this leaves us with one last question. Why would advanced civilizations want to leave the galaxy at all? What you're watching right now may be the answer. Sometime, a few billion years from now, indeed before our sun actually goes nova, the Andromeda Galaxy and the Milky Way Galaxy are likely to collide. And not only will the galaxies collide, the supermassive black holes at the center of both galaxies are likely to merge with unknown consequences. It may be that any civilization, regardless of how advanced, might want to stay clear of a cataclysm like this, and might instead want to go to the Triangulum Galaxy, the third galaxy that you're watching in this animation, that's going to stay safely away from all of this as it happens. And who knows, if we survive that long as a species and as a civilization, perhaps we may build our own Skotov thruster and make our way to another galaxy ourselves if we want to survive. Thank you very much for watching. I would like to thank the following incredible people: Rod Bowler, Michael Fireberg, John Morgan, Trevor Brown, Owen Densmore, Todd Trowbridge, Marcel Parnas, Affordable POS, David Schumann, and Alan Griffith. Thanks very much for your support. If you'd like to join these folks, all the details are in the description. And until next time, stay angry about space.